Hi, hello, welcome back to our channel Chemistry with RK. I am Raghu. Firstly, I would like to thank my viewers and students for continuous support. Within this very short span of time, almost my channel is reaching to 400 subscribers. So thank you so much for that, and then valuable suggestions. So I request, if anyone is new to the channel, so please do subscribe, and then don't forget to click on the bell icon for the regular updates. Okay, and then next let's continue with our previous discussion, that is solutions. So previously we were discussing about three concentration terms, that is weight percentage, volume percentage, weight by volume percentage. So next I am going to start a very important concentration term, that is the fourth one, molarity. Molarity, yes. Generally we define this with capital M. And now what exactly the term molarity defines? The term molarity defines that it is the number of moles of solute present in 1 liter of solution. So I am repeating, it is the number of moles of solute present in 1 liter of solution. So okay, so let me just write down molarity can be defined as okay, it is the number of moles of solute. Okay, generally we represent this with N1, number of moles of solute present in 1 liter of solution. And now generally volume of solution we represent with the capital V. Yes. So what does it mean? Now molarity can be defined as it is the number of moles of solute present in 1 liter of solution. So what does it mean? So we can write down that molarity M, nothing but number of moles of solute, that is N1 by volume of solution V. Actually we need to take this in liters. Yes. So this is what exactly molarity means. So in short we also can write down this as, yes, M is equals to N by V in liters. Yeah, this is what molarity. So I am repeating again, number of moles of solute present in 1 liter of solution is called as molarity. And now next we will move to its units. If we observe its units, so it is going to be, okay, molarity units. It is going to be mole per liter. If you see this, it is moles per liter. So we also can write down this as mole liter inverse, or we can also call this as molar. Very important. Okay, and now in place of this number of moles, we can also write down, okay, so next let us take this equation to the next level. So in place of this N1, that is number of moles, we can write down weight by gram molecular weight into 1 by volume in liter. Yes. And then this is also an important equation to solve the problems. And then we can also take, this liters. If we try to convert it to milliliters, then we get 1000 in the numerator. So this is gram molecular weight into 1000 by volume in liters. Very important. So this is the equation we are going to use to solve maximum number of questions which are related to molarity. Okay, so again I am coming back. This is very important concept for IIT, JEE and NEET. So it is the number of moles of solute present in 1 liter of solution, which can be written as M is equals to N1 by V, and then units, if we observe, since it is N1 by V, that is mole per liter, it can be written as mole liter inverse, which is called as molar. And then in place of number of moles, we can write down weight by gram molecular weight. So finally we are going to get weight by gram molecular weight into 1000 by volume in liters. Okay, next let's move to the dependence of temperature on molarity. Actually we can write, molarity is inversely proportional to temperature. And now this point is very important in terms of competitive exams, that is why and how these two terms are going to relate with each other. We know that molarity is equals to number of moles of solute present in 1 liter of solution. And now we know that as the temperature increases, obviously the volume of solution also increases. So which means that the temperature and volume of solution are directly proportional. And if you see here, the molarity and volume are inversely proportional. So that's why we can say that is, molarity is inversely proportional to temperature. Hope it is clear. And then the final equation we have got to calculate molarity is W1 by GmW1 into 1000 by volume of solution in ml. So this is what very important equation. So by using this particular formula, we can able to calculate maximum number of problems which are coming in different competitive exams. And now the additional information I am going to give. So in few questions, they use some kind of notations called as decimolar. Okay, so decimolar. So what do you mean by decimolar? So it is 0.1 molar, which can also be written as 10 power minus 1 molar. And then we can move to centimolar. Okay, so centimolar, actually this is 0.01 molar, or we can also write this as 10 power minus 2 molar. And then we will see something called as millimolar, which is 0.001 molar. And then this can be written as 10 power minus 3 molar. And then we can move to semimolar. Yes, there is a word called as semimolar. This can be written as 0.5 molar, or we can also write it as 5 into 10 power minus 1 molar. And then we have decamolar, that is actually 10 molar. So these are the notations we will be observing in different problems. So they will be mentioning, calculate the weight. Okay, they may ask you, okay, calculate the weight of NaOH present in 250 ml of, a decamolar solution or decimolar solution. So such type of questions will be possible from this particular concept. Okay, let's continue. Let us derive some more equations for the same molarity. Okay, so formulae. Actually, we know that molarity can be written as N1 by V in liters. Number of moles of solute present in 1 liter of solution. Okay, and now in place of this N1, we can write down W1 by GmW1 into 1 by volume in liters. That is, again, it can be taken to the next step, that is weight of the solute by gram molecular weight of the solute into 1000 by volume in ml. And now, so this is the final equation we have got already. And now let us just try to rearrange the things, and then please observe carefully. So is there any problem if we can write this equation in this way? So I am writing this as 100 into 10 by gram molecular weight. So the same equation, for our convenience, I have arranged like this. So I hope it is clear and there is no problem in understanding that. The same equation I have written like this, and then what we are going to get from that. So this part, if you observe carefully, this is nothing but weight by volume percentage. So yes, that we have already discussed in the previous video. So that is going to be weight by volume percent into 10 by gram molecular weight of the solute. And then next, if we want to convert this weight by volume percent to weight by weight percent, then we need to bring the density factor into the picture. That is weight by weight percentage into 10 into density by gram molecular weight of solute. So how we have converted this weight by volume into weight by weight percent? I hope you know that. We know that, okay, so that is density is equals to mass by volume. Actually we have, we can write volume is equals to mass by density. So since volume is inversely proportional to density, it is present in the denominator, so it will move on to the numerator. So that is how we are going to get this equation. And then next, I'm moving again to this particular equation, and if you observe carefully, that is molarity is equals to number of moles, very important, number of moles of solute, that is generally written as N1, by volume in ml into 1000. Yes, and then in place of number of moles, by using or by taking the help of a mole concept from stoichiometry, we can write few more formulas, that is the number of molecules, divided by Avogadro number into 1000 by volume in ml, very important. And now if we want to express that in terms of atoms, number of atoms divided by Avogadro number into atomicity. Yes, when it comes to number of atoms, we need to consider the atomicity, and then into 1000 by volume in ml. Okay, and then we can also write in terms of volume strength. So that is volume strength of, okay, so we can also write volume strength of H2O2 divided by 11.2 is the formula. So all these are the relevant equations which we generally use, or which are useful to us in solving the problems related to molarity. Okay, next let us see the relation between molarity and mole fraction. This is an important equation which is going to relate our molarity and mole fraction. So this can be written as molarity is equals to mole fraction of some substance A into density into 1000 by mole fraction of that A substance into gram molecular weight of that particular substance plus mole fraction of B into gram molecular weight of B. So this particular formula helps us in solving the questions related to mole fraction and then molarity. Okay, and then next let's move to our dilution law, dilution principle. So this is very important actually in the molarity concept, dilution law. And now, so what I'm going to assume is, in the first case actually, let us take, suppose let's say this is before dilution. I'm considering this case is before dilution. So let us consider this is the first case where the molarity of the solution before dilution is taken as M1 and then volume is V1, suppose. And now after diluting, okay, and then we even have, this is V1 and then the number of moles are N, suppose. And then after dilution, okay, after dilution, the molarity is going to convert or change into M2, suppose let's say, and then the volume changes to V2, but the number of moles will not change even upon dilution. That is very important. So that is after dilution. So what are the physical parameters are going to change here? That is molarity changes from M1 to M2 upon dilution. Volume changes from V1 to V2 upon dilution, but the number of moles will remain same. Okay, so make a note, that is number of moles remains constant. Number of moles remains constant even upon dilution. Very important, even upon dilution. So why sir actually? Okay, so by adding extra volume or extra solvent, we are going to see there is an increase in the volume but not in the number of moles. Number of moles will remain same. So the same concept we will use in the normality also. Please make sure you remember this. Okay. So if we apply the concept, the formula, the concept of molarity to this first equation, first condition, we can write down as M1 is equals to N1 by V1, and then similarly M2 is equals to N by V2. Yeah, this is what we are going to get. And now, since we can write down this as M1 V1 and then N can be written as M2 V2. Yes, and now since both of them represents the number of moles, let us consider this as equation 1 and equation 2. And now we can equate, okay, equating, okay, equation 1 and equation 2. So what we are going to get, that is M1 V1 is equals to M2 V2. And this is actually called as dilution principle. Okay, in terms of molarity, this is called as dilution principle. Yes, so we are going to use this formula also. So we will try to solve some questions. Yeah, let's solve this question related to molarity. So what is that they are asking? Calculate the mass of caustic soda present in 250 ml of 0.556 molar solution. Okay. So now what exactly? So first let us try to write down the given data. So to solve these questions, not only this particular concept, to solve any questions related to any particular concept, if we can able to bring out the given data, then our answer. Okay. So we will move close to the answer, I hope. Okay. So let us just try to write down the given data and make a habit to write down for every question. Okay. So given data is actually caustic soda. So caustic soda, actually what is the formula of caustic soda? Caustic soda is NaOH, sodium hydroxide. Okay, so they are asking us to calculate the weight of the caustic soda, and for that we know the gram molecular weight is 40 grams, because for one sodium it is 23 grams, and then oxygen 16 grams, 39, and then 1 gram for hydrogen, altogether 40. And then volume they have given it as 250 ml, and then the molarity also they have given that is 0.556 molar. Okay, and now what is the formula we have to solve this actually? So molarity is equals to weight by gram molecular weight into 1000 by volume in ml. Yes, this is what the relevant equation we need to use. So molarity is given that is 0.556 is equals to W1. We need to calculate the weight of caustic soda, and then it is 40 into 1000 by 250, so that goes 4 times, and then this is 1, and then 10 times. If we multiply this side, then the weight of the caustic soda we are going to get is 0.556 into 10, so that is going to come out as 5.56 grams. So this is how we need to make out the things. So I hope you understood. I am repeating. So calculate the mass of caustic soda present in 250 ml of 0.556 molar solution. So if you observe, the caustic soda is NaOH, and they are asking us to calculate the mass. They gave the volume, and then they gave molarity. So by looking at this information, we can understand that this is the required equation, and then if we substitute the values, and then we are going to get the weight of the caustic soda as 5.56 grams. And next, take another question. So calculate the weight of sodium oxalate present in 500 ml of decimolar solution. So this is a previous mains question. So let's understand the question. So what they have given sodium oxalate. So given data, the compound they have given is sodium oxalate, which is actually Na2C2O4. So this is called as sodium oxalate, and we need to calculate the weight of that. So that W1 we need to calculate, and the gram molecular weight of sodium oxalate is 23 into 2, 46, and then 12 into 2, 24, and then 16 into 4, 64. So it is going to come out as 134. Yes, the gram molecular weight of sodium oxalate is 134, and the volume they have given is 500 ml. And they have mentioned decimolar. As I told you already, the meaning of deci is 0.1 molar. Yes, this is the given data, and now we can use the same formula here. So that is 0.1 is equals to W1 by 134 into 1000 by 500. So this goes out with 2, and then this goes out with 70, 60, 67. Yeah, so 67. And now, so the weight of that sodium oxalate is going to come out as 6.7 grams. Hope you understood. Yeah, let's take another question. So that is the calculate the molarity of a solution containing 5 grams of NaOH in 250 ml of solution. And now what they are asking the molarity by giving weight and then volume. So how to derive the given data? So there is the given compound is sodium hydroxide, and its weight is given as 5 grams, and its gram molecular weight we know that just now we have discussed, that is 40 grams, and the volume they have given is 250 ml, and molarity we need to calculate. So if we substitute same formula we need to use here, that is molarity is equals to, so that is 5 by 40 into 1000 by we can able to get it is 250. So this goes out in 4, and then this goes out with 10, and then 5 by 10 is 1 and then 2 so 1 by 2. So the molarity is going to be 0.5 molar. So this is the answer. Hope it is clear. And actually not only these three questions actually. So the questions related to this particular concept will be coming with respect to this formula, or I have given a set of formulas, so we can able to get the questions from that particular those particular formulas also. So yeah, next let's move with the next question, that is calculate the molarity of 0.006 moles of solute of NaCl in 100 ml of solution. So let's try to derive the given data. So the compound they have given is sodium chloride, that's fine. And then I think if we observe here, they have given the number of moles, that is going to be 0.006 moles. And they gave that is the volume in ml as 100 ml, and then we need to calculate the molarity. So by observing this, we can have the formula, that is molarity is equals to N1 by N1 into 1000 by V in ml. So this is the relevant equation to solve this. That is molarity is equals to, they gave 0.006 into 1000 divided by 100. So this goes out with 10, and then if we multiply with this 10, so we are going to get 0.06 molar. So this is, let's see the next question. That is concentrated HCl has 38% HCl by weight with a density of 0.365 gram per ml, that is calculate the molarity of the acid. So yes, so the question is so very clear, that is, let us just try to write down the given data so that we can understand. So calculate the molarity of the acid actually. So they are asking us to find out the molarity, and then the given compound is HCl. So HCl gram molecular weight, actually we know that is 36.5 grams. For hydrogen it is 1, and for chlorine it is 35.5. And then what they have given the data, that is 38% of HCl by weight. So which means that they have given the weight percentage, that is 38%. Okay. Yes, and then if you see, the density is also given as 0.365 gram per ml. So by looking at this particular data, so we can understand that is molarity is equals to weight percentage. I gave you the equation for this, into 10 into density by the gram molecular weight of the HCl. Yes, if you see, and if like the data is given clearly, and then we need to calculate the molarity, that is the given weight percentage is 30, and then the given 38, the given density is 0.365 into 10 by 36.5. And if you observe carefully, this particular 36.5, we can write it as 38 into 36.5 into 10 power minus 2 into 10 by 36.5. So these two will get cancelled, and now this is 10 power 1, this is 10 power minus 2, 10 power minus 2 will be remaining, 10 power minus 1 will be remaining, and then the 10 power minus 1 into 38 will give us as 3.8 molar. So hope it is clear. So the given question, this question is one of the JEE questions. Okay, so please try to understand. Concentrated HCl has 38% HCl by weight, so which is nothing but this particular term they have indirectly given as weight percentage is 38%, and then density is given, molarity they are asking, so this is the relevant equation we need to use. Hope it is clear. Let's see the next question. This is related to the dilution principle. So how much water is to be added to prepare 0.12 molar solution from 100 ml of 0.3 molar solution? So which means that they have given two particular cases here, that is, suppose let us take A and B, and now for the A case they have given the molarity as 0.12 molar, and then they are asking the volume to be added. Okay, and then next in the B case they have given molarity M2 as 0.3 molar, and then we need to calculate this. They have given volume as 100 clear. So they are asking how much amount of water is to be added to prepare 0.12 molar solution from 100 ml of 0.3 molar solution. So what is that we need to add? So we have an equation called as m1v1 is equals to m2v2, which is dilution principle. And if we substitute all these values of 0.12 into v1 we need to calculate, and then 0.3 into 100. So if you just observe here 0.3 into 100, that is volume is equals to 30 divided by 0.12. So if you observe carefully, this value we are going to get it as 250 ml. So we have got the volume in this particular case, but they are asking how much volume of water, okay, volume of H2O added. So obviously volume of H2O added we can get by considering this 250, and actually already 100 ml is there. So how much extra amount of water is to be added? So that can be calculated by deducting 250 ml minus 100 ml, which is going to come out as 150 ml. So hope it is clear. They are not asking the volume, actually volume of this particular solution. They are asking the extra amount of water added to make this particular solution to prepare 0.12 molar solution from 100 ml of 0.3 molar solution. So I hope it is clear. So yes, next we will come with normality in the next video. Until that, take care, and then please I request you to subscribe, and then please suggest my channel to your friends, and then the students, those who are preparing for any of the competitive exams. Thank you so much. Have a good day.